While the battlefield map in Ukraine has changed very little in recent months, a different dynamic is unfolding across several sectors of the front. Military activity is increasingly defined not by dramatic territorial breakthroughs, but by sustained attrition that steadily reduces Russian manpower and operational capacity. According to the information described in the report, Russian forces are losing personnel at a large monthly scale, even in areas where the front line appears largely static. These losses are not the result of a single major battle, but are occurring through routine combat activity typical of modern warfare. One of the sectors where this pattern is especially visible is the axis between Zaparisia and Julie Eipole on the southern front. In this area, fighting rarely produces sudden advances or large armored assaults. Instead, combat is characterized by continuous pressure applied through small engagements, reconnaissance activity, and repeated probing attacks. Infantry groups move forward in attempts to identify weak points in Ukrainian defenses, but many of these attempts are disrupted before they can fully develop. Detection often occurs early, and movement toward staging areas or supply routes is targeted during preparation phases. In this environment, Russian infantry units frequently attempt infiltration using small groups rather than large mechanized formations. Armored vehicles have become increasingly vulnerable because aerial surveillance and precision strike systems can detect and target them early. As a result, Russian tactics have shifted toward smaller infantry teams sent forward to test Ukrainian defensive positions. According to the description provided, this shift reflects operational limitations rather than deliberate strategic choice, as large mechanized assaults have become increasingly difficult to sustain. Daily combat in the sector often occurs inside damaged urban areas, along tree lines, and within partially destroyed buildings. Exposure is high, and mistakes can quickly lead to casualties. Small clashes take place regularly, producing a pattern of losses that accumulates over time rather than during singular, large-scale battles. Russian casualties in the area result from repeated attempts to move forward, disrupted infiltration efforts, and withdrawals after encountering resistance. The outcome is a steady erosion of manpower instead of sudden spikes tied to major offensives. This steady drain on personnel is closely connected to the technological conditions shaping the battlefield. Persistent aerial surveillance conducted by unmanned aerial vehicles and other sensors now plays a central role in determining which movements are possible and which routes can be used safely. Roads, open terrain, and even temporary cover frequently become exposure zones where movement can trigger rapid response. In such conditions, detection often becomes more decisive than firepower. Once a unit is observed by aerial surveillance, it can be fixed in place, delayed, or targeted without requiring direct close combat. Russian infantry groups are frequently disrupted before they reach their assembly points, and supporting elements such as logistics and resupply units face similar risks when attempting to move. The result is a battlefield environment where attrition becomes systematic rather than situational. Losses do not depend on a single dramatic clash. Instead, casualties accumulate through repeated exposure during routine movement, coordination, and resupply activities. Units experience fatigue, reduced cohesion, and slower rotation cycles as they attempt to operate under continuous observation. Over time, the pressure compounds as each failed attempt to maneuver or regroup contributes to the broader erosion of manpower and operational momentum. In this context, the central question on the battlefield shifts away from which side is advancing on the map. Instead, the determining factor becomes endurance in a technology-driven war of attrition where every movement carries measurable risk. Maintaining operational presence becomes as important as achieving territorial gains. Ukrainian forces are increasingly shaping the battlefield around this principle. Rather than focusing exclusively on breaking defensive lines or capturing territory through large offensives, Ukrainian operations aim to create conditions in which Russian units lose people, equipment, and tempo simply by attempting to operate. Success is therefore measured not only by movement of the front line, but by how much pressure Russian forces must absorb in order to maintain activity. Within this framework, Ukrainian planners have identified a specific operational benchmark for attrition. The stated objective is to inflict between 35,000 and 50,000 Russian casualties per month. According to the description provided, this figure is presented not as political messaging, but as a practical indicator of whether pressure levels are sufficient to weaken Russia's ability to sustain combat operations. The benchmark reflects a broader shift in the way modern wars are planned and evaluated. Instead of seeking decisive battles that quickly determine outcomes, planners increasingly treat manpower loss as a cumulative process that can be shaped over time. In this model, the goal is not a sudden collapse of the opponent's front, but a steady erosion of their ability to function as an organized fighting force. The scale of these casualty targets becomes clearer when compared with historical precedent. During the Soviet war in Afghanistan, roughly 15,000 personnel were lost over nearly a decade of conflict. In contrast, comparable casualty numbers in the war in Ukraine are discussed in monthly terms. This compression of losses creates sustained pressure on manpower reserves and changes the strategic calculation of the conflict. High casualty rates force faster mobilization and shorten training cycles for replacement personnel. As a result, less prepared soldiers may reach the front more quickly, while unit cohesion and overall combat effectiveness decline over time. Even if numerical replacements remain available, maintaining the quality and coordination of formations becomes increasingly difficult under continuous strain. Under these conditions, the issue is no longer simply how many soldiers Russia can field. The more significant question becomes how rapidly the quality of those forces erodes as losses accumulate month after month. This attrition-driven environment now shapes the broader operational logic of the war, turning sustained pressure into a measurable objective rather than an incidental outcome of combat. Drone warfare has become the central mechanism through which this attrition strategy is implemented across the Ukrainian battlefield. Unmanned aerial vehicles now influence nearly every stage of combat operations, from reconnaissance and surveillance to strike execution and post-strike assessment. According to the information described in the report, drones are no longer used only to spot targets for artillery. Instead, they function as part of a continuous observation system that monitors movement, tracks activity, and enables rapid response in near real time. The key factor in this system is persistence. Drones remain in the air for extended periods, observing how units move, stop, regroup, and attempt to maneuver across the battlefield. This prolonged surveillance allows operators to identify behavioral patterns and anticipate likely routes of approach. When those patterns become visible, pressure can be applied selectively. Rather than reacting immediately to every movement, Ukrainian operators can wait until the most vulnerable moment, increasing the effectiveness of strikes and disruption. The result is a battlefield environment where the traditional gap between detection and engagement has narrowed significantly. Once movement is identified, units can be tracked continuously, allowing Ukrainian forces to respond with precision strikes, indirect fire, or targeted drone attacks. In many cases, Russian infantry formations are observed while they are still moving toward assembly areas. This prevents them from concentrating forces or choosing the timing of their assault. According to the description provided, Russian assault groups are frequently detected while still dispersed. By the time these units begin coordinated movement toward Ukrainian positions, their direction, route, and approximate size are already known. Ukrainian forces therefore engage them earlier in the process, shifting the point of contact away from the front line. Instead of confronting large attacks directly at defensive positions, Ukrainian units disrupt assaults during the preparation phase. This early disruption often prevents attacks from reaching Ukrainian lines at all. Small drone strikes, targeted artillery fire, or delayed movement caused by reconnaissance can break the cohesion of an assault group. Once coordination begins to fail, units may withdraw prematurely or lose the momentum necessary to continue advancing. As a result, many engagements end before they formally begin. Drone surveillance also enables targeted attacks on logistics infrastructure at critical moments. Ammunition depots, fuel points, and supply routes can be struck while Russian units are attempting to push forward. Interrupting logistics during active operations prevents follow-on attacks and limits the ability of Russian forces to exploit even small gains. According to the report, this dynamic significantly reduces the effectiveness of large infantry assault tactics. Mass assaults depend on concealment, coordinated movement, and sustained pressure on defensive positions. Persistent surveillance undermines all three elements. Movement across roads or open terrain is detected quickly, while pauses required for coordination expose units to additional strikes. The consequence is the pattern of high casualties without significant territorial progress. Beyond the physical losses, the report describes a growing psychological impact of continuous aerial observation. Russian infantry are increasingly operating under the assumption that they are being watched at all times. This perception affects behavior at multiple levels of command and control. Movement slows, units avoid direct routes, and commanders hesitate before committing forces to action. Routine activities, such as regrouping, repositioning, or resupplying, become sources of risk rather than normal operational tasks. Soldiers and officers must assume that any visible movement may trigger an immediate response from drones or precision fire systems. Over time, this constant pressure contributes to fatigue and increases the likelihood of mistakes during coordination or maneuver. Command and control also become more difficult under these conditions. Communication becomes more cautious, units spread out to reduce exposure, and assaults become shorter and less synchronized. According to the report, this gradual decline in coordination shifts the operational tempo in favor of the observer rather than the attacker. As airspace becomes increasingly dominated by unmanned systems, the influence of automation has begun extending from the air to the ground. Ukraine has expanded the use of unmanned ground vehicles, introducing robots capable of performing tasks that previously required human soldiers. What began as limited experimentation has developed into a structured capability where unmanned platforms operate alongside infantry units. These ground robots perform several functions. Some are equipped with heavy machine guns and can directly engage enemy positions. Others are designed for transport, resupply missions, or casualty evacuation. By distributing these roles across different robotic systems, Ukrainian forces reduce the need for soldiers to move through areas exposed to enemy observation and fire. The deployment of unmanned ground vehicles reflects adaptation to the conditions created by persistent drone surveillance. As aerial observation makes movement increasingly dangerous, robotic platforms provide a method of maintaining activity on the battlefield without exposing personnel to the same level of risk. One of the most important advantages of these systems is their ability to maintain presence in locations considered too dangerous for long-term human deployment. Robots can guard approaches, observe routes, or provide overwatch for extended periods without fatigue. Unlike human soldiers, they do not require rotation, rest, or protection from psychological stress. This capability changes how terrain is controlled. According to the report, control of ground is no longer defined solely by continuous human occupation. Instead, areas can be denied through surveillance and rapid response. If approaching forces are detected, robotic systems or supporting fire can engage them even if infantry are not physically present in the area. The result is a battlefield where terrain becomes contested because it is monitored rather than because it is constantly occupied. Russian units moving through such zones must assume that apparently empty positions may still be covered by sensors or unmanned platforms. This shift complicates planning at the tactical level. Routes previously considered safe may no longer be reliable, and pauses for coordination carry increased risk. Units must spend additional time checking terrain, waiting for safe movement windows, and adjusting their routes. These delays slow advances and increase exposure to surveillance. According to the report, such friction gradually drains combat power without requiring constant direct engagement. As these conditions persist, both sides continue adapting their technologies and tactics in an ongoing effort to gain temporary advantages in an increasingly automated battlefield. As the use of unmanned systems expands across the battlefield, both sides are increasingly focused on countering the technologies that shape modern combat. According to the report, Russia has introduced fiber-optic first-person view drones as part of an effort to bypass electronic warfare interference and restore the reliability of drone operations. Unlike traditional radio-controlled UAVs, these systems transmit commands through physical fiber optic cables. Because the control signal travels through a wired connection rather than radio frequencies, the drone remains resistant to electronic jamming and signal disruption. This design allows Russian operators to maintain stable control in areas where electronic warfare systems would normally interfere with or disable conventional drones. The tactical advantage of fiber optic drones lies primarily in reliability. They are typically used in short-range attacks at low altitude, where precise steering and uninterrupted control are more important than speed or payload capacity. In heavily contested zones where electronic warfare is active, this approach has allowed Russian units to continue conducting drone strikes that might otherwise fail. However, the use of fiber optic systems also introduces new operational limitations. Because the drone is physically connected to the operator by a cable, launch locations must be carefully prepared and protected. The flight path must remain predictable enough for the cable to extend without obstruction or damage. These requirements increase logistical complexity and limit flexibility during operations. Launch teams must operate in positions where the cable can be safely deployed, and they must protect both the launch site and the physical connection from disruption. According to the report, Ukrainian forces have responded by targeting the vulnerability created by this design. Instead of attempting to intercept fiber optic drones in flight, Ukrainian units have begun focusing on the control mechanism itself. Unmanned ground vehicles are used to locate the cables guiding the drones and physically sever them. By cutting or damaging the fiber optic line, the operator immediately loses control of the drone, rendering it ineffective. Ground robots are particularly suited for this task because they can move through rubble, vegetation, and trench networks without exposing soldiers to danger. Once the cable is located, the unmanned vehicle can sever the line directly. This approach demonstrates a shift towards system-level warfare, in which the goal is not simply to destroy individual weapons, but to disrupt the networks and connections that allow those weapons to operate. The exchange between fiber optic drones and robotic countermeasures illustrates how rapidly battlefield technology is evolving. Each innovation is followed by new countermeasures, forcing both sides to adapt continuously. Systems that initially appear to provide a clear advantage can become vulnerable once their operational dependencies are understood. In this environment, the battlefield increasingly rewards forces capable of disrupting processes rather than merely destroying equipment. Command networks, communication links, and logistical chains become key targets because disabling a single connection can neutralize multiple systems at once. As countermeasures develop, the operational value of technologies such as fiber optic drones can decline due to increased preparation requirements and reduced flexibility. At the same time, Ukraine is adjusting how it organizes and sustains its own technological warfare capabilities. According to the report, the country has introduced the Army of Drones bonus system, a framework designed to link battlefield performance directly with access to equipment and resources. The system functions as a performance-based structure, where results achieved during combat generate measurable points. Under this model, actions such as eliminating enemy personnel, capturing prisoners, or destroying military equipment are assigned specific point values. These points are recorded and can later be exchanged for new equipment, including drones, sensors, unmanned ground vehicles, and related technologies. Units are able to acquire these systems directly from manufacturers through a decentralized procurement process. The objective of this system is to shorten supply cycles and ensure that effective tactics are rapidly reinforced with additional resources. Instead of relying exclusively on centralized distribution chains, units that demonstrate results can replenish equipment more quickly. Combat performance therefore becomes directly connected to logistical support, creating what the report describes as a closed operational loop, in which success on the battlefield leads to faster resupply. This structure also encourages tactical initiative. Small teams operating drones or other unmanned systems can act independently within broader command priorities. Because results translate into tangible equipment support, units are incentivized to identify opportunities, adapt quickly, and maintain operational tempo. Senior military leadership continues to define strategic priorities and operational limits, but execution within those boundaries becomes more flexible. According to the report, this approach reflects a broader transformation in how modern warfare is organized. Advantage is no longer determined primarily by the number of soldiers deployed, but by the speed at which a force can observe, strike, assess damage, and rearm for the next action. In a battlefield environment dominated by drones, sensors, and automated systems, speed and efficiency become critical strategic factors. For Russia, this evolving structure presents additional challenges. A military system built around centralized command and slower logistical processes may find it difficult to match an opponent that emphasizes rapid adaptation and decentralized action. Even when manpower remains available, converting those numbers into effective operational pressure becomes more difficult under conditions defined by constant surveillance and technological competition. Taken together, these developments illustrate a broader transformation taking place in the war in Ukraine. Combat operations are increasingly shaped by unmanned systems, persistent observation, and continuous attrition, rather than large-scale armored breakthroughs. Machines perform many tasks that once required soldiers, while surveillance networks allow strikes to occur with increasing precision and frequency. The conflict therefore highlights a new model of warfare, in which control of information, rapid adaptation, and integration of systems can be as decisive as the number of troops on the battlefield. Analysts note that militaries around the world are studying these developments closely, as the lessons emerging from Ukraine may influence how future conflicts are planned and fought. For viewers seeking deeper analysis of modern warfare and its consequences, consider subscribing for further reporting and updates.